So, welcome to the law of signs, the ambiguous case. We've looked at two situations where we had where we could use law of signs. We had two angles and a side. The other case where we can use law of signs is when we have two sides and an angle. And the difference is with these two cases with two angles and a side, we were able to find one triangle that could be made with those three given measures. But when we get to the side-side angle or the ambiguous case, there's a possibility that we may not be able to make a triangle at all, or only one triangle will be able to be made with those measures, or we could possibly have two different triangles. So that's why it's ambiguous. We don't know what situation we're going to have. So let's talk about how this could happen and how we can figure out how many triangles or solutions we'd have. So with the ambiguous case, you're going to be given an angle and two sides. So we could say the ambiguous case is angle, side, side, or the PG version would be side, side, angle. Okay, so we are given a fixed angle. We know the angle or the side opposite that angle, and then we're given an additional side. So what we're trying to figure out is the side opposite our angle long enough to make one exact triangle, or is it long enough to make two triangles, or maybe it's too short and won't make one triangle at all. So that's what we're going to be trying to figure out. You can do that another way, but it can be a little confusing and tedious. So we're going to talk about a nice basic way that you can use every time and will get you to the right result. So let's take a look at what this means. So if we have no triangle or no solution, then that means the side opposite is too short. Okay, in a lot of these pictures, they'll draw the altitude, which is the distance from that vertex to the opposite side that is perpendicular, because that is the shortest distance from this vertex to this side. So if that side opposite the given angle is shorter than that altitude, it's not going to be long enough to get down here to make the triangle. Okay, so if it's too short, then you're going to have no triangle. It could be just long enough that it could either connect straight down or it could actually connect out here. Okay, so it just depends. But in this situation, 5 is the shortest distance. So this side, if it connects out here, would have to be longer than 5. Okay, so I could have just one exact triangle. Or if the side opposite, it could be long enough to come down here and make a triangle, or short enough that if we swing it around, it's short enough that it could come down here and connect. So we could have two triangles. We could have an obtuse triangle out here, or we could have one acute triangle this way. Okay, so that's what we need to try to figure out. Okay, and we can do that by using basically our calculator. Okay, so you're going to let's go back here for a second. So what's going to happen in this ambiguous case? You're going to be trying to find this angle B. Okay, opposite that other given side. And you can determine when you use law of signs what you get for the sign of angle B will tell you whether you have no triangle, one triangle, or two triangles. Okay, so when you set up your equation for law of signs, you're going to be coming up with an equation that will calculate angle B. Angle B will be an acute angle, meaning between 0 and 90, because that's what your calculator is programmed to give you. Okay. However, there is another angle who will have the same value of sine, and that's because let's look at this situation here. If this is length A, this side is length A, then if I would swing that around, this side, these two sides are congruent or equal. That means my triangle here has two sides that are equal, so the angles opposite those two sides are equal. So for example, if this angle B is 20 degrees, then this angle over here is also 20. Okay? Which means there's an angle that is the supplement of 20, meaning two angles add up to be 180. So this angle right here, if I call that theta, I could say theta plus 20 has to equal 180. So that angle theta would be the supplement of 80. Okay, so that means that this angle B that we're given from our calculator, its supplement could be also be an angle that would make another triangle. Okay, and the reason for that is because there are two angles that have the same positive value of sine between 0 and 180. So for example, if I say the sine of some angle theta is 1/2, okay, then I know there is an angle in quadrant 1 whose sine is 1/2, and that would be 30 degrees. Okay, so theta is 30 degrees, which is in quadrant 1. However, sine is also positive in quadrant 2. So there's an angle in quadrant 2 whose reference angle is 30 degrees, which that angle in quadrant 2 is going to be 180 minus 30, which is 150. Okay. So that means that there are two angles that satisfy this equation. It has two solutions. 30 degrees, which is an acute angle in quadrant 1, and 150 degrees, which is an obtuse angle in quadrant 2. So we have to check. Once we get this acute angle, we're going to have to check to see if its supplement, the obtuse angle, could also make another triangle. So let's take a look. Here are the steps that you have for determining how many triangles you have. So we're going to follow these steps as we go through the procedure. So it's kind of like we just talked about. What you're basically trying to figure out, when you find the sine of that angle, you would like to know if that value is greater than 1 or if it's between 0 and 1. And then you can make the determination whether you might have no triangle or you might have 1 or 2 triangles. Then we'll talk about the supplement and seeing if it works. Okay, example 1. So notice how I'm given an angle and two sides. So and that one of the sides is opposite the angle. So that's how I know I can use law of sines. All right. I always draw my triangle in the same situation. So whatever angle I'm given, it's not always called A, but whatever angle it is, I put here. Okay, the side opposite is here, 18, and then the other side I always put over here on the left. Okay, so that means if this is little b, then this is angle B. Okay, so the next thing I'm going to try to find then is angle B. So I'm going to set up my equation for finding angle B using the law of sine. So the sine of angle B over the length of the side opposite is equal to the sine of another angle that we know, which is 76 degrees, over the length of the side opposite. So I now have an equation that I can solve for B. First thing I'm going to do is solve for the sine of B so I can make my decision. So to find the sine of B, I take 20 times the sine of 76 degrees, and I divide by 18. Okay, now I want you to put this in your calculator. What do you get? Okay, so when I put that value in the calculator, I get 1.078. Okay, so what that's telling me is it's saying there's some angle whose sine is 1.078, which is greater than 1. And if you recall, the sine of any angle has to be between -1 and +1, right? The range is from -1 to +1. So this is not possible, which you would then find out if you put that in your calculator, if you did the inverse sine. If you said, okay, I'm going to let the calculator tell me angle B that has that sine. So you can put this decimal in, or you could have put this exact expression in. So when you put that in your calculator, what happens? You get domain error or error on your calculator, okay? Which is exactly what we just talked about, because it can't be greater than 1. So if you can't get an angle, what does that tell me? Or tell us? There is no triangle. What that means is this side 18 is too short. So technically, if I drew it to scale, it would be too short. It wouldn't come far enough. It's not long enough. If we would calculate this altitude here, then 18 would be shorter than that altitude. Which, if you just want to see it one time, it's kind of fun to see, I can use my triangle, my right triangle here. Whoops, that's wide. Okay, and I can calculate the length of that altitude by using SOHCAHTOA. So the sine of 76 degrees is the side opposite over the hypotenuse. And if I solve that for h, that'd be 20 times the sine of 76 degrees. So h is approximately 19.4. So we can see then that that side, if 19.4 is the shortest distance from this vertex C to this side down here, then 18 would not be long enough to make it. Even if it went down this direction, it's still too short. Okay? So there's a situation of what happens if you have no triangle. Okay, so let's take a look here. Once again, I'm going to set up my drawing the same way. I have an angle, side opposite, and another side. So this is a law of sine situation. So I have angle A is 39 degrees. The side opposite, little a, is 23. And my second side that I've given, I'm always going to put it over here. Okay, so little b is 9. So I'm trying to find angle B. Okay, well, my guess is I'm going to be able to make a triangle because 23 is quite a bit longer than 9. But what I want to know, is it long enough to make one triangle, but short enough that I could swing it around and make two triangles? Okay, so once again, set up a proportion to find angle B. So the sine of B over 9 is equal to the sine of 39 degrees over 23. So to find the sine of B, I cross multiply and divide. And when I put this in my calculator, I get good question. Oh, 0.24625, etc. So I'm saying that the sine of my angle B is 0.24, etc. So that tells me then that the sine of B is between 0 and 1. So, which means that we do have a triangle. Okay, so I can find this angle B by doing the inverse sign, and you can always go with just putting this exact value in, okay, or put it on your calculator and then do the inverse sign of that decimal. But 9, you want to use the exact, do not round and then find the angle. Okay, so this gives me angle B is approximately, and I'm going to round to 2 decimal places, 14.3 degrees. Okay, so basically that's telling me that I do have at least one triangle. Okay, I've got one triangle. Now, what I want to know is there a second triangle that could exist? Okay, so what do? We take that value, okay, and we find its supplement, okay? So if I say this is, and now they'll call that B1 because that's this angle B in your first triangle. It doesn't matter how you label it as long as you can keep the two triangles straight, okay? So to find B2, meaning the obtuse angle, this is acute. We want to know what's the obtuse angle that has that value of sine, meaning in quadrant 2. So we want the obtuse angle. All right, so to find that second angle, B2, then it's the supplement of B1. So, so then we subtract 14.3 from that. So the obtuse angle we would get comes out to be 165.7. Okay, so what I'm trying to figure out is if I have this triangle, just a quick visual, if this is A and this is B, if this is 39, could this angle B be 165.7? Is that possible? Well, look what happens. When I take angle A, 39, and I add 165.7, I get 208.7, which is too much, right? This is greater than 180, which means this is too much here, so I can't add in my third angle. So is it possible to have a second triangle with that obtuse angle in it? No. Because that's greater than 180, there is no second triangle, okay? So I do have one triangle, but there is not a second triangle. So basically, I have one triangle, and then I would go ahead and continue to solve that triangle, okay? So, and then it's basically what you've been doing, so it's nothing new. So if I bring this down here, I know my angle B then is, let's see what I say, 14.3. Okay, so you could put 14.3 in here. You would then go and continue solving. We'll do it one more time here just for a review, which means then I need angle C, which is going to be up here, and then I need the side opposite. Okay, so once we've got two angles, we can find the third angle. So I can find angle C then by subtracting the two that I know from 180. So C comes out to be 29.3 degrees. And then to find the side opposite, we would set up a proportion. So C over the sine of 29.3 is equal to 23 over the sine of 39. So I always just use those original values. So when I cross multiply and divide, I get so C should come out to be, if you round to a couple decimal places, oops, I got the wrong C. That's the problem with lowercase and uppercase. Sorry, that's the side. I apologize. This one should not be 29.3. I should have noticed that, but no, I didn't. I'm too big of a hurry. This is 126.7. Which is one thing you should always do, is go back and double check. So this is 29.3. So these should add up to be 180, or close if you had to round. And then check, longest side is opposite biggest angle, shortest side is opposite smallest angle. So here I have one triangle, and here's the solution. Okay? So, of course, we've got to look at a situation with two triangles. So when we set it up, I've got A is 40, side opposite, little a is 14. Additional second side would be B is 16. Okay. So that's B, so this is angle B. This is little a. All right? Okay, so when I set up a proportion to find the sine of B and angle B, and solve, I get sine of B is 0.7346, which is less than 1. So I know that I do have an angle. And that acute angle is 47 degrees. Okay, so what I need to figure out then is, so that tells me I do have one triangle for sure. So I want to know, is there a second triangle? So what do? We find the supplement of that. So is there an angle B in a second triangle? Because that'll be our B1, the angle B of our first triangle. All right, so I take 180 minus that angle, 47 degrees, and I get 133, excuse me, can't do the math. Okay, so what I want to know is, will that make a triangle? So if I had this angle is 40, and no, this triangle is not drawn to scale, and this angle is 133, do I still have some degrees left for this third angle? So 40 plus 133 plus this angle has to be equal to 180. So if these two add up to be more than 180, we're in trouble. Which, what is it? 173. So there are still some degrees here for that third angle. So what does that tell me then? I have a second triangle, because this sum here, the sum of these two, is less than 180. So is there a second triangle? Yes, there is. Okay, so what I do is I like to draw two separate pictures. What this means is that if I look at this side, it's 14. It's long enough to come down here, but it's short enough that if I swing it around this way, it's going to meet down here. So this is my B1, this would be my B2. So that means I have, I've got this other angle. This is my angle, 133 degrees. This one is 47. Okay, so I like to separate it and make two pictures and label it appropriately. So I've I like that altitude in there because it kind of gives you an idea is if I swung it around, it would be over here. This is that side. Whoops, that wasn't so good. Okay, so I've labeled those two angles. So here's where we can the three measures that we were originally given, angle A, side A, and side B, will be the same in both triangles. So notice how they have not changed. Okay, what will be different is now angle B here is 47, so angle C in my first triangle then is going to be 40 plus 47 and 180 minus that. So this angle is going to come out to be 93 degrees. All right. And then you would finish solving, meaning you'd find C1. So you'd set up a proportion to find that side C, like you've always done. And then choose another pair of sides. I like to choose the given always, so it's not using rounded values. Okay, so you'd find side C1, cross multiply divide, which gives me approximately 21.8. So that means then that this side here will be 21.8. And then I like to summarize it. This is my first triangle. Okay. So then you just go over here to triangle 2 and do the same kind of procedure. Finish solving. All right, so this angle is going to be 7 degrees, which we know it had to be really small. Whoa, 7D. Where did that come from? Oh, come on. All right, so this angle is 7 degrees. So little c, when you find this side, comes out to be 2.65. So this will be 2.65, which I know you can set up a proportion. And then you could check that as well. So here are my two different solutions, the measures of that would make two triangles. So fun times, it's exciting. It's like a birthday. You never know what you're going to get.